All right, so today in class we did a form of division, a strategy for division that you may not have seen as a parent or as a guardian. This is a different way of dividing. It is called scaffolding. It allows students to use partial quotients that they are familiar with. These partial quotients are subtracted from the dividend until the dividend is smaller than the divisor. So, for example, if I have the problem 259 divided by 5. Okay, so in this type of division problem, not all the students will choose the same multiples to subtract. So what we do is we look at this as a whole number, 259. And we say, kind of estimate, 5 will go in 260 or 250, about how many times. And it's called scaffolding. It's supposed to look like a building on this side, a tall building with scaffolding. So we know that 5 will go into 25, we'll go into it 5 times. So 55s, since it's a multiple of 10, I just add on that 0, would be 250. Then we're going to subtract to see what we have left. 9 minus 0 is 9. 25 minus 25 is 0. Then how many times will 5 go into 9? Well, 2 5s is 10, so I know I could only do it one time. 1 times 5 is 5, so my remainder is 4. And then I take my scaffolding over here, 50 plus 1, and my answer would be 51, remainder 4. And I also try to teach them to go ahead and write it up here, because this is where we will put our quotient when we do the standard algorithm. So this is called scaffolding. And this is a method of division that we learned today in class. We also are going to be talking about area models again, like we did in multiplication. I take the same problem, 259 divided by 5, and I want to do an area model. I put my dividend inside the box here, 200 plus 50 plus 9, decomposing the 259, divided by 5, so it's 5 times something equal 259. So then I need a partial product here, here, and here, and I will add those together. So 5 will go into 20 4 times, so it'll go into 240 times. 5 will go into 50 10 times, and 5 will go into 9 1 time. So that's 51, and then I would have a remainder of 4, because 5 will go into 9 1 time with 4 left over. So this is how you would do an area model to divide the same problem. And then, of course, we will have our standard algorithm, which I can show you on this problem. So 4 going to 30 7 times. 7 times 4 is 28. 30 take away 28 leaves me 2. Bring down my 6. 4 going to 26. 6 times. 6 times 4 is 24. Subtract. 2 left over. Since 2 is less than 4 and there's nothing to bring down, I'm done. So my answer is 76, remainder 2. So we divide 40 into 30, then we multiply 7 times 4, subtract, and then we bring down. And as soon as you bring down, you have to start all over. Divide, multiply, subtract, bring down. Alrighty. And so those are our 3 ways of division. I'm going to do one more scaffolding since it is new, just so you can see. Draw my scaffolding here. Oh, that's the same problem I just did, sorry. Okay, so we're going to do this one, 424 divided by 8. And some kids will pick different multiples. I know that 8 will go into 45 times, but if I don't want to do 50, they may want to choose 20. which is what's really great about the scaffolding. It's not everybody will choose the same one. So 2 eighths is 16, so 20 eighths is 160. Subtract. So I have 264 left, so I still have quite a bit. Say I want to do another 20. Then I could do 160. Subtract. I have 104. No, it will not go into 20 times again because that's 160 and I only have 104. But I could do 10. 10 times 8 is 80 and have 24 left over. And I know 8 will go into 24 3 times, which is 24 with no remainder. And then you just add up these 4 on my scaffolding, 20, 40, 50, 53. So my answer would be 53 and I have no remainder.